Let's begin with this qualitative model. Remember that risk is a probability times a consequence. But in the case of the Asian carp, the presumption is if the Asian carp become established, there will indeed be unacceptable consequences. So there's not a great deal of effort that's going into quantifying consequences. That means the key to this risk assessment is quantifying this probability of establishment and estimating the probability of establishment. In the qualitative risk assessment, the probability of the Asian carp becoming established was rated as medium. So when time came to make a quantitative risk assessment, we looked at these elements that you're looking at here, and we thought, okay, the probability of a pathway existing is easy. That's a 1. We can see it. The probability that Asian carp will arrive, well, that's something that we can estimate with some expert elicitation. There's no data, no hard data for this. But then that became a little bit more complicated because we had to ask ourselves, what arrives? 1 Asian carp, 2 Asian carp, what arrives? So we decided that we would look at the probability of arrival of a small, a medium, and a large population. So that value became a little bit more complicated. When we moved to the probability of passage, we began to think about the passage of a single fish. What's the probability that one fish can pass through the existing system? But then we realized that doesn't tell us a whole lot that's useful for colonization. So we began to think more about this probability of passage of how many fish, because the number of fish that passes is very important to the probability of colonization. So it was within these two elements in particular that we ran into problems. But if we got colonization, the probability of spread would not be that difficult to get from our experts either. So I'm going to show you the model that we are now working with. Don't be frightened by the look of this. We're not going to go into the details, but I'm going to try to lay out the model in this video, and then in subsequent videos I'll explain how it's used. So we have 3 different time periods that we are interested in. Time T0, which would be a base year, and the time T0 calculations are all in this light gray. So you'll see here time T0 right here. And then we have time T10. That's 10 years later. And that is all in this particular shade of gray that you see right here. And then we would also have a part of our model that is relevant for year T50. And that is the darkest gray section that you see. And that's for years T11 through T50. Within this model, you can see 3 clusters of calculations. Don't worry about the calculations just yet. I'll explain those later. This first cluster assumes that a small population arrives. The middle cluster assumes that a medium population arrives. And by the way, that middle cluster is for a medium population for all 3 time periods. The third cluster assumes that a large population arrives. So when we come back and look at this model in the next video, you'll have some sense of how it's laid out. The final calculations that we're going to be looking at are found up here in the first 4 rows. We have year T0, and you'll see there's some probability of colonization given that we have arrival of the aquatic nuisance species. Then there's some probability of spread. Multiply those 2 together and we get the probability of establishment. What you don't see are the first 3 elements. Those first 3 elements are now handled in these calculations down here. But as I said, we'll handle that in the next model.